This problem is from GATE 2021 Mechanical Engineering paper of set 1. The question is, consider a vector P in two-dimensional space. Let its direction counterclockwise angle with the positive x-axis be theta. Let P be an eigenvector of a 2 into 2 matrix A with corresponding eigenvalues lambda, where lambda is greater than 0. If we denote the magnitude of vector V by double modulus of V, identify the valid statement regarding P prime, where P prime is equal to A into P. Now 4 options are given here, among which we need to find the correct answer. Now to gain more knowledge on eigenvalue and eigenvector, you can follow the course provided by NPTEL on deep learning by Professor Mitesh M. Khapra of Department of Computer Science and Engineering at IIT Madras. So in the problem it is given that there is a vector P vector, let it be xi cap plus yj cap. So this P vector can be represented on a 2D plane as, now suppose this is the x-axis and this vertical axis is the y-axis, and this small arrow in the direction of x-axis is the unit vector in x direction, and this blue arrow is a unit vector in y direction. Now suppose this is a vector P vector whose endpoint can be represented in terms of matrix as x, y. Now according to the question, the magnitude of P vector can be written as double modulus. So this is the magnitude of P vector. Also, it's given in the problem that this P vector makes an angle theta with the positive x-axis in the counterclockwise direction. It's also given in the problem that there is a 2 cross 2 matrix A whose eigenvector is P and eigenvalue is lambda, for which lambda is greater than 0. In a linear transformation of a matrix A multiplied by a vector P is equal to lambda P, where P represents the eigenvector of A and lambda is the eigenvalue of A. Now let this be equation number 1. Also in the question it is given that P prime is equal to A into P. Now let this be equation number 2. You can pause the video here, and with the given information and the concept explained here, you can try to solve this problem, and if needed you can further go on and see the complete solution of this problem. Now let's continue to solve this problem. First we will substitute the value of P prime is equal to AP in the first equation, that is AP is equal to lambda P, where P is the eigenvector and lambda is the eigenvalue. So if we substitute, we get P prime is equal to lambda P. Now in the problem it is also mentioned that magnitude of any vector V is given by double modulus of V. So the magnitude of P prime can be written as like this, is equal to, now the right hand side also we will put the same symbol, and since lambda is the eigenvalue which is a scalar quantity, and or we can say it is a constant quantity, so we can take lambda outside and we can write double mod of P vector. So the magnitude of P prime is equal to lambda into magnitude of P vector. Now what about the direction of P prime? How do we find the direction of P prime? From above equations, from equation 1 and 2, we have already seen that P prime is equal to lambda times of P vector. And we know that lambda is the eigenvalue and P is the eigenvector. Now let's try to understand the eigenvalue and the eigenvector on a 2D sheet. Now here I hat and j hat represent the unit vector in x and y direction respectively. Now let's suppose there is a vector P prime on this 2D plane. Since we know that lambda is the eigenvalue and P is the eigenvector of matrix A, this P prime is also equal to A into P. Now after linear transformation, when we multiply A with P, we get P prime. So if P is the eigenvector of A, that means P must be having the same direction as that of P prime, because eigenvectors are those vectors which do not rotate when the linear transformation is performed. Now after linear transformation, P prime can get squeezed or it can get stressed, and that depends upon the value of lambda. Suppose lambda is greater than 1. In this case, P prime vector will get stressed because lambda is greater than 1. Suppose if lambda belongs to 0 to 1, in this case P prime will get squeezed because lambda is lesser than 1. And of course if lambda is equal to 1, so the value of P prime will be the original value. But one thing to notice here is, even though the value gets squeezed or it gets stressed, the angle will never change. It will always remain theta. Also, this stretching or squeezing of this vector P prime is already calculated here in the magnitude of P prime, that is equal to lambda into the magnitude of P vector. Now we can say that the direction of P prime is same as that of P vector, counterclockwise from the positive x-axis. Now let's match our answer with the given options. We see here the direction of P dash or P prime is equal to theta, and the magnitude of P prime is equal to lambda into magnitude of P vector. Hence option B is the correct answer. Hopefully I was able to clear your doubt with this problem. Have a great day. Thank you.